So let me show you something that same group and others pushed on a little bit more recent of handling occlusion. So the question is, you know, if a thing gets partially occluded, we have this problem because remember the eigenface stuff is it's capturing the entire image as a vector. And all the pixels, all the components in that vector are created equal. So if some of them are sort of being blocked or obscured, it's not going to be able to explain that data. It's not going to be able to track, give you a very high probability at that area. But it turns out you can address that if you think about the following, right? By the way, that's Greg Dudek a while back. Hi, Greg. Picture there. When I reproduce an image, so let's suppose I've tracked this thing, I've computed my eigenbasis, and now I'm trying to find my best one, and I do. I can now say, of all those pixels, which ones am I reconstructing well? The ones that I'm reconstructing well, those are the ones that I have a lot more confidence in. So let me create a weight mask that says, you know, those pixels are fine. But anywhere that I find something that I can't reconstruct well, I'm going to highlight those pixels as ones that I'm not going to pay attention to. By the way, the reason I'm saying highlighted is on the video I'm about to show you, for whatever reason, they have sort of bad pixels as being bright. So you can think of them as being highlighted for not counting as much in the current or the next iteration. So what you're going to see here in this video again is, so here's Greg's face that's going to be tracked. And this is the sort of the location of what they're doing. But what you'll see here is there'll be this black image, and then all of a sudden you'll see his hand swipe up across his face. Now, of course, his hand is not easily reproduced with the face eigenbasis. So you're going to see that light up. And that's it saying, okay, the weight of those pixels should be reduced. So let's see if this works. Ah, there it goes. It's playing. Okay, same thing we see before. You see his eigenvectors changing on the bottom as he rotates in and out of the plane. Whoops, there was his hand. Did you miss that? Let's go back again. Now get ready. In a minute, he's going to swipe his hand over his face. There it goes. Did you see that? You can play it backwards. As his hand came up, the weights got brighter where the hand was, saying ignore this place. And now it tracks him for a while. He's smiling, he's getting large and moving around, and you can see it's doing a good job tracking. You can see the difference between how well it can be reconstructed. And the reason it can handle things like this is, remember, the state that it's tracking is position, translation, rotation, scale. So you can normalize it back to the original sort of canonical view and explain that view from the eigenbasis. All right, so that's some pretty cool tracking work.